So for the thermo project, we got the middle stack of the air conditioner. So we got our fan set up down here at the bottom to blow air through the bottom of this, up through the tube and out through the bottom, which is our outlet over there. And then as the fan is going and the pump is going, I am pouring desiccant through the top to where the air can blow across it, dehumidifying the air. And then that's gonna go up through the other stack and down through there. We have a gauge inside that is wetted, so we can get the wet bulb temperature of inside the stack along with the dry bulb temperature of outside. And then as this is being pumped up out here, it's going to be sent back into the first stacks to be dehydrated again. So here's it working.
And we are measuring the wet bulb temperature of the inside, right?
Yes.
Okay. And theoretically, that should have a different wet bulb temperature than the outside because the air has been dehumidified. Like our wet bulb temperature right now is 69 degrees Fahrenheit, and our dry bulb temperature outside is about 10 degrees higher than that, about 78.2, 78.5.
And then as you can see, it's pumping the desiccant back out through the bottom of this stack, back into a little reservoir we had, so we didn't make a mess everywhere. But that would be, in theory, if it is entirely put together, back into the first stack to be dehydrated. And the reason we chose to do it outside is because inside it's already air conditioned, so the humidity is already pretty much taken out of the air inside. So this gives us a better way of doing it, more scientific way of doing it. That way the air is humid, and we're trying to dehumidify it inside the stack to see what our values are once we use the psychrometric chart.
All right, so looking at the psychrometric chart here, our ambient air temperature settled around 81 degrees Fahrenheit. We didn't get that on the video, but it just kind of fluctuated around there, and by the time the video was over, we looked over some more data, and it settled around 81 degrees Fahrenheit for the dry bulb temperature. So that's the temperature that we decided to pinpoint for the psychrometric chart. So, and another temperature that we didn't get in the previous video was the wet bulb temperature for the outside air. That wet bulb temperature seemed to be around 72 degrees Fahrenheit. And so with the wet bulb temperature and the dry bulb temperature of the ambient air, we are able to locate a point on the psychrometric chart, and following the line over to our absolute humidities, it appears that our humidity seems to be about 0.015 pound mass of H2O per pound mass of dry air. And that is our absolute humidity. And our relative humidity looks to be about 68%, looking at the sloping lines, sloping down from the right to the left. So that is the data for the dry air that we picked up. Our dehumidifier stack seemed to do a relatively good job in terms of dehumidifying, because once again we have an 81 degree dry bulb temperature, but the wet bulb temperature drops down to about 69 degrees. So following that line over to the psychrometric chart, we end up with about 0.0128 or 129 thereabouts pound mass H2O per pound mass of dry air. So we have a lower absolute humidity inside of the stack with the dehumidified air as compared to the outside ambient air. And following the slopes leading down from the right to the left, sloping down to the left for relative humidity, it appears that our point is located about the 58% mark, or the 58-59% mark. So our dehumidifier was successful, it appears, in terms of lowering the humidity of the air, and that is seen in both absolute and relative values. And that was it for the presentation. Thank you so much for watching.